Hello, welcome to Sherry's Fun Fan Classroom. In this video, we will introduce the speed regulation method of AC fans. In the previous video, we introduced that the AC fan has an asynchronous motor inside. It has a simple structure and low cost, so it is very popular in the market. However, asynchronous motor has a fatal shortcoming that it is difficult to adjust the speed. The current mainstream speed adjustment method is variable frequency speed adjustment, so it must be used with an inverter. Firstly, it increases the cost. Secondly, the harmonics generated by the inverter will also affect the service life of the fan and cause serious problems such as fan vibration, noise, and heating. Therefore, our AC fans do not have the speed adjustment function when they leave the factory. However, in order to fulfill the needs of our customers, this video is dedicated to explaining the speed adjustment of single-phase AC fans with string capacitors.
Next, let me demonstrate to you all and explain the capacitive speed regulation of AC fans. The fan I have chosen is from EBM W3200HK3801. 3 capacitors with different capacitance values have been prepared. Series capacitor speed regulation is the process of connecting a capacitor in series in the main circuit of a fan, introducing capacitive impedance, then change the voltage at both ends of the fan to achieve speed regulation. Take a look at the nameplate of this fan. This is a unidirectional capacitor starting AC fan. Its rated voltage is 230 volt. The current is 0.29 ampere. The power is 64 watts. The rotational speed is 2550 revolutions per minute. To test the operating status of the fan, and there are also parameters. The starting capacitance of this fan. It is already prepared from the factory. When wiring, just follow the fire, 0, and ground the power supply to the top of the fan. There will be labels L and N on this terminal and the grounding wire. We just need to correspond with them. The wires are already connected. Adjust the power supply voltage to 230 volts. Adjust the frequency to 50 Hz. Then power on the wind turbine. Now the fan has run smoothly. The current is 0.29 ampere. The power is 58 watt. Measure the rotational speed again. The speed is 2620 revolutions per minute. Let's keep track of the current data. Insert capacitors into the main circuit later. Measure again afterwards. This is capacitor with capacitance of microfarad. I want to connect it in series in the main circuit of this fan. Let's first connect one end of the capacitor to the live wire of the power supply. Connect the other end to the fan. I'm already connected online now. Now let's power on and test it. Now the speed has basically stabilized. The speed is around 875 revolutions per minute. The current at this time is 0.14 ampere. The power is 10.4 watt. Compared to before adding this capacitor, it has already dropped a lot. Let's measure the voltage at both ends of this fan. It can be seen that the voltage at both ends of the fan is only 72 volts now. Now we will replace the capacitor from 2 microfarad to 3 microfarad. The wiring process is the same as before. Now I have replaced this capacitor with 3 microfarad. Let's measure its rotational speed. The rotational speed is around 1980. The current is 0.2 amperes. Power is 25 watt. Measure the voltage at both ends of the fan. Voltage at both ends of the fan is 124 volts. After replacing the capacitor with 3 microfarads, the voltage at both ends of the fan has increased. So what if we switch to 6 microfarads? Measure again. The current at this time is 0.48 amperes. The power is 106 watts. The rotational speed is around 2650 revolutions per minute. Measure the voltage at both ends of the fan. The current voltage at both ends of the fan is 281 volts. On the contrary, it is even larger than my power supply of 230 volts. After adding a capacitor of 6 microfarads, its current and power have both increased when the speed is relative to that without capacitance. There has also been a slight improvement. So why is this? Through the test just now, we found the smaller the capacitance value of the capacitor, the more obvious the effect of speed reduction is. The larger the capacitance value of the capacitor, the more obvious the acceleration effect is. Let's analyze it briefly. The AC fan uses an induction motor internally. Induction motors rely on supplying AC power to the stator coil, generate a rotating magnetic field, drive the rotor to rotate. We can consider the fan as an equivalent series connection of electrons and inductors. At this time, we will introduce another capacitor in its main circuit, transformed into an RLC series circuit.
Although the cost of series capacitor speed regulation is low, small impact on the fan, but due to the continuous charging and discharging of capacitors, the power factor is very low, reduced the efficiency of the power grid. If customers have speed regulation needs, you can also suggest choosing our AC fan. Follow us to learn more.